The pi theorem. There are several methods of reducing a number of dimensional variables into a smaller number of dimensionless groups. The first chain given here was proposed in the 1914 year by Buckingham and is now called the Buckingham pi theorem. Let me write Buckingham pi theorem. The name pi comes from the mathematical notation pi. The name pi comes from Buckingham, a mathematical notation pi, meaning a product of variables. The dimensionless groups found from the theorem are power products denoted by dimensionless groups. Pi 1, pi 2, pi 3, and the method allows the pi groups to be found in sequential order without resorting to free exponents. The first part of the pi theorem explains what reduction in variables to expect. So the first part of pi theorem if a physical process satisfies the PDH and involves a non-dimensional variables, if a physical process satisfies the PDH, finds the PDH, which is the principle of the homogeneity, principle of the dimensional So if a physical process satisfies the PDH and involves n-dimensional variables and involves n-dimensional variables, it can be reduced to a relation between only k-dimensional variables or pi's. It can be reduced to a relation between only k-dimensionless variables or pi. Between only k-dimensionless variables or pi's. The reduction J equals to n minus k equals to maximum number of variables that do not form a pi among themselves and is always less than or equals the number of dimensions describe the variables. So let me write the reduction n minus k equals to maximum number of variables that do not form a pi. And is always less than or equals the number of dimensions describing the variable. Take the specific case of force on the previous example in this chapter, which was F equals to a function of, for example, the F equals to a function of rho V. For example, we have rho V and L. 5 variables available: F, L, U, rho, and mu. Yeah, 1, 2. Described by 3 dimension. So they are variables, dimensions, M, L, T. So we have n equals to 5 for variables and j is smaller than 3. J should be smaller than 3. Therefore, it is a good guess that we can reduce the problem to k pi group with k equals to reduce to k pi groups. And a minus j equals to a minus j, and this is exactly what we obtain. 2-dimensionless variables p1 equals to cf and another pi equals to Reynolds. One rare occasions it may take more pi groups than this minimum. The second part of theorem shows how to find the pi groups one at a time. So let me write the second principle part of pi theorem. Find the reduction j first. Have to find pi groups one at a time. How to find pi groups one at a time. At first, find the reduction j. J equals to n minus k, parameters minus the dimensions. Select j scaling variables that do not form a pi. Select j scaling variable. that do not form a pi among themselves. A pi among themselves. Each desired pi group will be power product of these j variables plus one additional variable. Each desired pi group will be a power product of these j variables, j plus one additional variables. Which is assigned any convenient non-zero exponent which is assigned any convenient non-zero exponent. Non-zero exponent. Each pi group thus found is independent. Each pi groups thus found independent. To be specific, suppose the process involved in this example. For example, consider a variable v1, the function of parameters, and v5. Suppose there are three dimensionless. Suppose there are our dimensions M, L, T, and we search around and find that indeed j equals to 3 because we have 5. So in this case the number of dimensions are 3 and the number of variables are 5, j, n. So k equals to n minus j, 5 minus 3, 2. These are the, say that there are only one and only 2 pi groups. Pick out 3 convenient variables that do not form a pi and suppose this turn out to be v2, v3 and v4. So suppose the 3 variable v2, v3 and v4 do not form a pi. This is an example. Then the 2 pi groups are formed by power product of the 3 plus 1 additional variable, either v1 or v5. So we can obtain the pi groups as the relation pi1 equals to we have only 3 parameters that do not form a pi, so we have a relation for v2, v3 and v4. v2, v3 and v4 multiply to v1. These 3 parameters that allocated powers do not form pi, and this is the product that help us to find the first pi, and the second is pi 2 v2a v3 b v5 c multiply to v5. Also we have the same condition here. For example, do not form pi and help us to first pi. Typically, 6 steps are involved to analyze a problem with pi theorem. Steps are involved. The first step is the list and count the n variables involved in the problem. List and count the n variable involved in the problem. If any important variables are missing, dimensional analysis will fail. For example, in the relation S equals to our variable are S and T, and our parameters are S and G. So there are maybe 2 pi theorem. The second is the list the dimensions of each variable according to list the dimension according to MLT theta and FLT theta also. A list is given in the appropriate table in chapter 5. For example, for S we have L, and for T in this equation we have T, the dimension of our variable 3. Find J. Initially guess J equals to the number of different dimensions present. Find J equals to the number of dimensions in all variables. Select J scaling parameters that do not form a pi product. J scaling parameters that do not form a pi product. a pi product. Make sure they please you and have some generality if possible, because they will then appear in every one of your pi groups. Pick density or velocity or length, for example. Do not pick surface tension, for example, or you will from 6 different independent Weber number parameters and truthfully annoy your colleagues. 5. Add one additional variable to your J repeating variables. To your J repeating variables. And form a power product. So in this case we can find the number of pi product n minus j. 6. Write the final dimensionless function and check the terms to make sure all pi groups are dimensionless. And check the terms to make sure all pi groups are dimensionless. All pi groups there are various examples related to this part in the solution videos. You can check the example there.